All right, so last time we finished up talking about an array stack. And one of the big emphasis, obviously, when we learned about the array stack, we learned about implementing a stack. But there were a couple of other key parts about this lecture that was really important. It was emphasizing the fact that we are implementing a stack interface. That is the definition of what a stack is and what you can do with it. The implementation was the how it's done. But those are separate things. The interface doesn't need to know how, it just needs to know what. The implementation needs to know, well, what and how, because it actually implements the what. But when we go to use the stack, all I care about is the what, the interface. And we also learn about that idea of generics, which was a fancy way of saying it's like having a variable for a type. That's what that means. All right, a little more on unit testing. So of course we know unit testing is very important. Never ever do anything with untested code. It's reckless, and until you've tested it, it's as good as not working. I don't care if it's untested and you think it works, I don't care, prove it by writing tests. It's not my job, like I'm your prof, but like let's say I'm just some other programmer and you gave me code. It's not my job to convince myself that your code is correct. It's your job to convince yourself and me that it's correct. And that's why we're writing these unit tests, and we write them well. The trouble is, unit tests aren't too bad to write when they're for those simple classes, those simple ones, like the plain old Java class, like the country, the friend, the course. Those are relatively simple to test. And part of the reason they're simple is, well, there's really not a lot to them, it's just data. And the data, we made it immutable, meaning we can't change it, so it actually eliminates a lot of potential like functionality and testing that we need to do, which is a good thing. We like that. The trouble is, the data structures have a lot of functionality, and they're very stateful. They're mutable. We can change it, and they're going to change their state. And the way that it should operate based on its state is going to be different, so there's a lot we have to test. And it's a pain in the ass. Writing tests for anything stateful, writing tests for collections is a very tricky, challenging thing to do. But there are some coping mechanisms we can follow to make it a little less painful. And I'm gonna walk through some of these things. So one of the things we'd like to emphasize during the course is we like immutability. We like to avoid side effects. And we like functions to be very independent from one another. This is another big aspect of it I didn't mention a moment ago, was when we have a function, we like them to be like independent from one another. But when you have something like a data structure, well, the add and remove are kind of like connected, right? They're like inverses of one another. So those functions are they're really not that independent from one another. We make them as independent as possible, but there is some connectedness to it. It's hard to kind of deal with. Collections pose a problem because they are mutable, they have side effects, and a lot of the methodology is very interconnected. And their expected behavior depends on their particular state. So consider pop. What should happen when we call pop on an empty stack? What should happen when we call pop on a stack with one thing in it? What should happen when we call pop on a stack in general, when we've got some arbitrary number of things in it? That's going to depend on, well, what's the state? If it's empty and we try to pop, who remembers what should happen based on our implementation? Yeah, an exception, right? It's just like, well, you can't pop from an empty stack. What happens when we call pop on a stack with one thing in it? Well, a couple of things. One, when we call pop on a stack with one thing in it, we should get the thing back. We should also end up with an empty stack after, right? If there's one thing on the stack, we pop from it, the state of the stack should be such that it's now empty, right? And what happens if you call a pop on a stack with multiple things on it? Well, we should return the stack, but the size of the stack should be reduced by 1, so it's not quite, it's tricky. But we're going to break this down. We're going to write these tests in a systematic way to make it a little easier to write these things. All right, so we're going to start with, pardon me, we're going to start with tests for an empty stack. Let's pick one state and then do all the methods for that state. Then we'll go to the next state being like there's nothing in the stack, there's one thing in the stack, etc. So we're going to stick with one state and write all the tests for those, all right? Okay, perhaps simplest test is when it's empty. Below our example unit test for all methods when it's empty, all right? So here's a bunch of tests for a stack that's empty. And we're going to look at them in a moment. But consider the two push-related tests. There is a test that it returns what's expected. And there is also a test to check that it had the proper side effect. This is an example of the added complexity of testing things with side effects. But let's have a look. What are the methods we have? We have push, pop, peek, is empty, size, equals toString. But we don't write the equals ones. I wrote those already for us, so we're going to kind of ignore them. Writing equality on these things is tricky. But that's what we got to test for. So when I call pop or push on an empty stack, it better return true, right? So here's what my test is going to do. And remember, I know a moment ago I said, well, there's like multiple things you want to test for like a pop or a push. There's what it returns and the side effect. But we want to test those things separately. Obviously, they're related, but remember, one of the key points of unit tests is we want the tests to be passing or failing on a very specific thing, right? It's possible that it returns true, but it didn't have the proper side effect. And if that was both one test, it would say fail, but I wouldn't know why. Did it fail because it didn't return true, or did it fail because it didn't have the proper side effect? It's better to have two tests. That way, if one fails, I've got a very specific reason why it failed. So, push, empty, returns true. Remember, we're going to follow that pattern of method name, state, condition, whatever we want to call it, and then what's expected. So push, empty, returns true. So we create a new stack. A new stack is empty by default. And assert true. Class under test push. Oh, class under test is the name of my reference variable to the stack. This is a common thing. You name the reference variable for the class that you're testing. This is what I always call it. So if you're always wondering why is it always called class under test, it's because that's what I call it. So when I call class under test.push 11, 11 is some arbitrary value, not overly important. I expect to get true back. If I ever call this function and it doesn't return true, we got a problem in this particular situation. The test would fail. Push empty has a new top. So we create a new stack, we push something onto it, and then assert equals 11, class under test peek. Remember, peek returns a reference to the thing on the top. We're in a bit of a pickle here, though, because this is an example of methods being like inextricably connected to one another. And I can push something. This is a test for push, but I'm calling peek. So we hope that it better be right, because we're kind of stuck. These two methods are so connected, I can't test one without the other. So we're kind of screwed in this situation. It is what it is. Not the best situation, but by nature of the fact that all of these methods are very coupled and dependent on one another. It's very stateful. It's immutable. There's side effects. There's a lot going on. So assert equals, I'm going to have to call peek. Because otherwise there's really no other easy way for me to get the top. At least, and remember also, here's a big key thing I want to say. When we test these things, we test the interface. Obviously we're testing the implementation, but we're testing it from the perspective of what does the interface tell me I can do. So if you're like, well, no, you could just go in the array and check in the array. We're not supposed to know about the array inside the array stack. That's hidden from us. That's a private detail. A stack is a stack. So there's our push empty has a new top. Pop empty throws a no such element exception. Checking for checking if an exception was thrown. The syntax is a little funny. It looks like that. I honestly never remember. I always go look up what I did last time and just copy what I did because I can never remember. But that's the magic way we do it. It's because the reason we have to do it a little differently is because exceptions aren't like returned. They're like a special separate type of side effect. So it's not like we could check what was returned by this. We have to check like listen for this other fancy weird side effect. So that's why the syntax is different. Don't worry too much about it. It's the magic code. So much so that that's what I always tell myself. I go like, whatever, deal with it. This is the way I have to do it. You might remember from Python, when checking for exceptions, it was weird too. So if you're like, oh, Java's weird, Python was just as weird. In fact, it's actually a little easier in Java than it was in Python. In Python, you had to use like a with keyword. It was a whole thing. So pop empty throws the exception. Peek. Now, there's no other test for pop. I guess I could write a pop to check that the state of the stack didn't change. I could have. It's still empty. But it can't return a value because it would if it's empty, it's always going to raise the exception. So we can't check if it returned true or sorry, the element. I could have written a test here to be like, okay, peek empty, still it's still empty afterwards, but that I think is a little overkill, especially because the exception it just stops functioning, nothing's going to change. Because remember, as soon as an exception is thrown, the method immediately stops executing. In a similar way that as soon as a return statement is hit in your code, it stops executing at that line. All right, peek empty throws an exception. Is empty empty returns true. Size empty returns 0. ToString empty returns empty string. Now, this is defined. The expectation of this is defined by how I wrote my ToString, so I have to test it accordingly. I'm going to need that extra comma, like you brought up last time. Not in this case, though, because it's empty. So there, we've got a bunch of tests for an empty stack. It's only for the empty case. I didn't test for the singleton case, when there's only one thing in it. And I didn't test for the many case, when there's a lot of things in it. Do we have any questions about these tests here? On assignment 1, how many of you spent time really looking at the unit test for country catalog like you were supposed to? Yeah. Well, shame on you. There was like a billion of them. Yeah, I know, right? And if you thought for a second, oh man, all these tests, do you know how much of a favor I did for you by giving you those tests? Most profs aren't that nice. You're welcome. And you don't even know how nice I am. Gee, you need to appreciate me more. All of those tests, what makes those tests good is obviously it helps you know correctness. You want to get your points, right? But be honest, when you ran the tests and 2/3 of them passed, but a bunch failed, and it said failed in this particular condition. How many of you were like, oh shit, I'll go fix that condition? Yeah, exactly, right? So the tests are good at not only ensuring correctness, but But when it's incorrect, they tell you where. Isn't that amazing? Not always. There's going to be times, like there were some people that were like, why is this one failing? I'm like, well, it's probably failing because of this funny thing over here. And that can happen. But that's a consequence of things being kind of inextricably kind of interconnected and hard to pull apart. So there's the empty tests. What's this note here? Yeah, the name of the reference variable is class under test. This is a common convention. Use the name class under test for the object being used to test the class. It's a very common pattern. It's not as much of a, it is a convention, but it's not a convention to the point of like, in Java, all your classes start with an uppercase, and if you don't, you're committing a sin. If you didn't do it in like your unit tests, no one would say you're committing a sin if you didn't use the name class under test, but people would be like, yeah, you're pushing it though. You should use the name class under test. All right. You may have noticed in all of these methods, there is some common code. Specifically, the creation of an empty stack. And there's nothing wrong with doing the tests like this, but if you see some common code and you're like, can we kind of like extract that common code out? Absolutely we can. We can create a special method and give it a tag. The tag is important. At before each, and what this means is immediately before running each individual test, run this code. Big surprise. Run the code to create the instance to test it. What's nice about this is, one, it extracts common code. It's always kind of nice to not have repeat code all the time and have it in one place. But two, it does separate the creation of the thing and the actual thing you're testing, right? So now when you look at this, push empty returns true, the only thing in there is really about the test now. So it's kind of nice. Now the catch of doing something like this is we need to make class under test a field for the whole class. Basically, you declare it outside of the methods within like the test class. And then it exists, and then you can actually create an instance in that before each. If it wasn't a field, we wouldn't be able to access it in the other methods. So we make it a field, and then we actually create the instance with the before each. If at any point you're looking at this and you're saying, how am I going to memorize this? You're not. Just look at existing ones whenever you need to make your own unit tests. Look at existing unit tests and copy what you need and change accordingly. Any questions about this common setup code, the at before each? Often, these tags that we add, in like Java proper, for lack of a better term, when we have these tags above our methods, it doesn't really have anything functionally meaningful or overly important for us, like the at override or at suppress warning and whatnot. That's just like a tag for like the Java compiler. But these tags are important for JUnit. JUnit is the separate testing framework we're using. So at test is important here. It needs to be there in order for Java to know, oh, this is a test. Okay, I need to actually treat it as such. You're too quiet. No questions, no nothing? Everyone's happy? It's just you're all so good at writing tests, right? Okay, so we did the empty state. Now let's do the singleton state, the state when there's only one thing in the stack. All right, notice the inclusion of a new class field pre-state. The pre-state will effectively be a duplicated class under test that can be used to check if the method had no side effect or a side effect. I'll make this clear in a moment. But here's the example. Consider peak singleton unchanged. When I call peak, peak should have two things I want to test for peak. One, when I call peak, it returns a reference to the element on top. Two, it better have left the stack alone. So I create a duplicate stack, a stack that is identical to class under test in every way, Then I can check, okay, are they equal after calling peak? If they're equal, it didn't change. You'll see what I mean in a moment. Although pre-state is actually only used in one of the tests so far, it's convenient to always have an equivalent copy around. So if you're like, this feels like overkill for one test, yeah, but this is a nice thing to have. We like having a duplicate of the thing we're testing because it's going to come in handy. So here's a before each, okay? I'm now excluding the empty tests, the state for when it's empty, because whatever, we saw them. I just put like a tag in that code right there saying like, okay, they should exist. I'm just excluding them for now. And now let's look. Push singleton returns true. Push returns. I'm adding these two pushes here because I want the stack to have one thing on it. Then I'm going to push onto a stack that has one thing on it, meaning there should be two things on it. But either way, when I push a stack that already has one thing on it, it should still return true. When I push, it should have a new top. Right? Peak should be 11. Pop, well, I should get the thing at the top, which should be 10. Right? If the stack has 10 on it and I pop, I better get 10 back. Pop should result in a new empty stack. If the stack has one thing on it, I pop, the resulting stack should be empty. So that's what this test is doing. Push, we could ignore pre-state for now. Pop, well, class under test better be equal to an empty stack. Warning, I'm using equals, assert equals, which is going to use the class's definition of equals. If I didn't write that, it's going to default to sameness, the default equals check. So this test actually requires that the equals method is implemented. I've given it to you though, so whatever. Peak singleton returns top. Peak singleton unchanged, right? So pre-state and class under test better be equal after I do a peak on class under test, right? Because look, class under test has 10 on it, pre-state has 10 on it. They're both stacks with one thing on it, both 10. They're equal. I call peak on class under test. Again, I'm always pointing over there, I know. I call peak on class under test. And then pre-state and class under test better be equal after peak, meaning peak had no actual change on class under test. Yeah? Yeah. Is empty singleton returns false. Size singleton returns 1. ToString returns correct string, written as it needs to be based on how I implemented the ToString. Notice that like push, pop, peak, is empty and size had well-defined, before I implemented the array stack, those methods had well-defined, this is how they must operate. Before I ever implemented them, there was no question on how do I do it? I know how to do it. It's defined. ToString, I had a decision to make. ToString, how do I want to represent this as a string? That was up to me. But ToString wasn't in the interface though, right? ToString is just something we like to implement to get a nice string representation of something. So the ToString was not defined by what a stack is. But push, pop, peak is empty size. They got to work the way they got to work based on what a stack is. All right, what do I have on this note? When considering peak, singleton returns top. It may become clear that push empty new top and push singleton new top are redundant. Push empty new top and push singleton are redundant. Since peak singleton return top will test peak after a push anyways, this was me going back to the point that peak and push were kind of tested together. It's still nice to have separate tests though, I think, for completeness sake. Otherwise, it might get kind of confused by what was included and why didn't I include the peak, right? I'm seeing a lot of blank faces, so I don't know what that means. One thumbs up, you speak for everybody. Thank you. All right. Yeah, this highlights the complexities of the interconnectedness of the collections methods. You can't test push without knowing what the top is with peak. You can't test peak without having something pushed on it already. You just can't. All right, so a couple of notes here. Okay, we could now go on to writing the tests for the many case, when the stack has some like 5 or 10 things on it. The number doesn't really matter as long as it's not empty or size 1. We can start writing these, but there is some nice we can write this code in a little cleaner of a way. Like how I was able to extract that common setup code. You might notice all of these singleton tests had some common code in all of them too. All of them required me to push something onto the stack. But we can't put that into the before each, right? Because if we did, that would break all of the empty tests because there would be stuff on the stack. So I can't put it there, but it does feel kind of lame that I've just got all this duplicate code. Well, there's a trick to that. We could do nested classes for our tests. What I mean is we could put a class, we could write a test class inside a test class. If this sounds like, whoa, we're putting a class in a class, don't think about it as being a class so much as a subgroup of tests that we can write. So, okay, notice once again, each of these tests have the same setup code. Unfortunately, unlike, yeah, I just said that. Okay, so here's what we're going to do. I'm going to have my before each. Then I'm going to make a subclass called when new empty. The name of it doesn't really matter, but when new empty I think is a damn good name because it's the case for when the stack is new empty. Notice that the setup code is actually outside that nested class. And then inside this class, meaning between this squiggle and the closed squiggle eventually, will be all of the singleton tests, most of which are excluded for brevity here. But then still within that class, I'm going to make a new class called class when singleton. It's got a tag at nested that has its own setup code. This setup code depends on the setup code that came in like the outside class. Meaning class under test already exists and it's a new empty stack. Now I'll push onto it. So I can put all of these singleton tests, instead of immediately below the empty tests, I put them in a subclass within. And it really is within, because this is the closed squiggle for the when singleton, or sorry, when singleton. And then this is the close for when new empty. There would be another close for the whole class that all of this is in. And now for the more general case, well, we have when new and empty, when singleton, and then we have to have an extra tag. Just include the magic code. We need it there. And I've got another before each that adds additional things. This builds on top of the previous nested classes existing before each. Meaning, class under test not only exists, it had 10 pushed on it from the singleton tests, and now once we're in the many tests, it's also going to push 20, 30, and 40. So for all of the tests inside when many, I have a stack with 10, 20, 30, 40. And now what would the test look like? Well, push, it returns true. Pop, many returns top. Pop, many returns top. Pop, many has a new top. Peak, many returns top. Peak, many unchanged, is empty, and so on and so on and so on. So I just have all my tests here for the many case. And then we have a close, 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 close. I'll close them all. So we've got tests inside of tests, inside of tests, inside of tests, inside of tests here, the unit tests. But it's actually just a way that I find, if this feels confusing, I think once you do it once or twice, if you tried to do it without these nested classes, you're probably going to find your tests are going to start to feel really complicated. This might look complicated, but once doing it once or twice, and having done it without it, you'll probably really quickly see, oh no, this is a much nicer and cleaner way to kind of like keep track of and keep my tests organized in a nice way. Remember, when in doubt, go reference the existing test classes that I give you and make changes accordingly for your needs. Someone in lab yesterday asked, is it okay to like copy the test from another one and just change it? Yes, do that. That's a good thing. We like that. So if we go here, let's go actually look at, tests. Array stack test. And here is the whole test class for array stack. I've got a bunch of imports. I just always add whatever IntelliJ tells me I forgot to add. I never remember. There used to be a time where I used to have to remember that stuff, and then the IDEs did it for me. It's a great day. Array stack test. That's the convention, name of the class, followed by test. I think in Python it was the same, right? I've got my two fields, array stack, class under test, pre-state. You'll notice that I'm choosing to test it with the generic type of integer. That's arbitrary, doesn't matter. If it works for integers, it's going to work for strings, it's going to work for booleans, whatever. Class under, okay, before each, we create two empty stacks. And then we have our when new empty. Do all the checks. When singleton, before each, we add our one thing to both the pre-state. It's called pre-state because I've got class under test. That's the things I'm going to test. I call it pre-state because they're equal before every test starts, right? So if the test modifies class under test, well, what was it like relative to its like pre-state? That's why I call it pre-state. There's all my singleton tests. When many, add a bunch more and a before each. That means this before each runs before every individual one here. Do all the tests. I also have one more set of tests down here called when large. It's actually not nested inside all the way. It's actually only nested. It's not nested in any of the other test classes, even though it says nested. I guess it is because it's in here. This basically is a way to check that expand capacity ran. Now, if you're thinking to yourself, well, hold on. You said test the interface, and the interface doesn't give a shit about expand capacity. Expand capacity was a private method, and that's dependent on the specific implementation, the fact that we used an array in the array stack. So why are you writing a test for like an implementation detail, not the interface? And you're absolutely right. I have that there because we're all still learning, and you might mess up your expand capacity, so those tests are there just in case. Any questions about these tests?
Why are like the when singleton and when many tests nested inside of the
Say the question again.
Like, when new empty, inside of that also includes the when singleton and when many test.
Mm-hmm.
But like, is that really necessary? Because if they weren't nested inside of it, the before each for the creating the class under test would still run before them.
So I could net, so is what you're saying, let me clarify. Is what you're saying is, well, I can see that when many is nested inside in when singleton because
It's pushing the 10 first.
the 10, we want that to be there first. But the when singleton doesn't really need to be nested inside the when new empty because this before each actually isn't inside there.
Yeah.
So you're right. I don't think that would, but if I did it that way, I think the code would become a lot less clear. So it's just a design decision for like code clarity. Functionally, not that important. Design-wise, I think it's important. But good observation nonetheless. Other questions? Cool. Good nuanced observation though, yeah. Make sure you take some time to look at these tests to get a feel for what is actually tested. What am I testing? What am I not testing? Does that make sense to you? Writing tests are the other half of it's the other side of the coin of all the code we write. So if you're not comfortable writing tests, like at this stage, I'm giving you like all of the tests. At the end of the semester, I make you write your own tests for things. So at this stage, although I'm giving you the tests, you gotta write tests. So you gotta get used to looking at them and getting a sense for what's tested and what's not. And unlike writing the code, where I feel like when you're writing code and methods and functions and classes and whatnot, I find it to be a lot more, personally, I find it to be much more like straightforward. I need to write a function that takes this and gives me that. Like I'm writing a function, right? There's no mystery about it. It's just it's a deterministic function that when it sees this, it gives me that. When it sees this, it gives me that, and so on. When it comes to writing tests, tests feel a lot more like an art than a science to me. It requires a bit more of like a gut intuition on what's a good test, what needs to be tested, and what not. And the only way you're going to develop that, like your other programming skills, are still going to be with like exposure, practice, looking at these things to get a feel for what's there and what's not. Last chance for questions on these unit tests for the collections. So who remembers how many unit tests there were for the country catalog? 73, right. And some of those actually had like subtests in it, right? So there was probably even more, really. The country catalog is actually a relatively general data structure. Obviously, it's not generic. It's designed for countries. But if we made it generic, suddenly we actually have this fairly general purpose thing. It's almost like a list in Python. A stack is far more narrow. It's not very general. It's got very specific functionality. And as a consequence, the number of tests that we need to go for it, write for it, it's minimal, which is nice. But you can still see it's quite a bit. And as we go and we look at more complex data structures, the number of tests we're going to have to write are going to grow a lot. But that really is a consequence of, don't get me wrong, it's a consequence of like growing complexity of what we're building. But the growing complexity of what we're building is kind of a consequence of the fact that data structures are intrinsically side effecty, mutable, that interconnectedness of functionality. It's those things that make it a pain in the ass to test, really, ultimately. By the way, it is entirely possible to write, and I've thought about this, and maybe people in here try to remind me to ask you this question at the end of the semester. It's entirely possible to write data structures, to like implement them in such a way where they are entirely immutable, where they don't have states. And you might think, how is that even possible? That doesn't make any sense. They seem like naturally, like in and of themselves, they're stateful. You add something to the stack, it's there now. Well, the way you do it is every time you add something to a stack, you create a new stack with that thing added to it. The original stack was left alone. Nothing changed about the original stack. It's just we made a copy with the required change. And suddenly it would become immutable. And these tests would get a little nicer, I think. And there's something to be said about implementing things like this. That means there's no side effects. Your data is immutable, that's a good thing. These are things we really like. But there are some downsides. Imagine pushing and popping a billion times. We got to make a billion different stacks instead of one stack we're pushing and popping to. So there is some overhead associated with that. But there is a niceness. There's a very big niceness that we're missing out on by having stateful data structures. There are some nice mathematical properties that we like about immutable stuff. But we are going to do it with states and whatnot, because I think it's a little easier to wrap our head around when it comes to programming it and what it means and how we use it and whatnot. So that's why we're doing it. But I'm curious, maybe at the end of the semester, I'll try to remember to ask this question again of like, do you think it would have been better to make it everything not have a state? Any questions before I go on to the next topic? All right. All right, now for a bit of a change of pace. Links. Before I carry on, I want to emphasize something here. What I'm about to describe to you is not a data structure. It's going to be more analogous to an array, an underlying container, not a data structure. And I'm also going to warn you that, and I might be jumping ahead too much, but I'm going to say it now anyways. Often, actually no, I'll bring this up later. I think I'll just confuse you. Remind me later. So, links. This is not an ADT. This is an underlying container that we could use to implement a data structure. Okay? When using an array, data, what do we like about arrays? Well, they're simple. We get them for free. They're just like right there when you load up Java, just make an array. The data is in contiguous, it's contiguous in your array, which is nice, although not necessarily actually in the computer RAM, but that's irrelevant. It's contiguous, you can index it really easy. Indexing is really easy. But the downside is, like if I ever wanted to like put something at the beginning of that array, I have to like move everything down. And if I wanted to remove something, I got to like move everything around a lot. So it's easy to like navigate through an array, but it's kind of a pain in the ass if I want to like move something in the array and then I'm going to have a whole, got to do a lot of shifting around. There's a lot of work involved with that. There's nothing wrong with that. It's just be aware of the pros and cons of the tools you're using. Traditionally speaking, arrays are in contiguous memory. The successor values in like the next array cell. Java virtual machine asterisk, and Java arrays are objects, and objects go into the heap, which isn't necessarily contiguous. It doesn't matter. It's just for the asshole in the room that's like, well, technically, I know. So, link structures. Here's the idea. A linked data structure is one that consists of objects referencing other objects. Actually, I shouldn't really call it a data structure, a linked structure. I want to get rid of the word data there. A linked structure is something like this, okay? It's made up of things that we call nodes. Really, it's just a series of nodes. The thing that we have in aggregate, we call it like a linked structure. Sometimes people call this a linked list. Do not call it a linked list. Don't do it. It's a linked structure. When you call it a linked list, I'll explain why it's terrible in like a month. We call it a link structure. But the link structure itself isn't an object. It's a series of nodes. The nodes are the objects. There is no link structure object. It's just that these nodes are like strung together, linked together. Okay, good. It wasn't just me. Okay, link structures do not have a fixed size like an array. With the linked idea, data does not need to be stored in consecutive memory at all. Successors can be anywhere in memory. And data can be inserted and removed by updating the references and links without having to shift a lot of stuff around. And I'm going to show you examples of this very shortly. The core basic building block of our link structure, which really, when I say building block, I mean like it really is the only thing that is a link structure. It's made up of several of nodes. A node is going to be an object that has two fields. One of the fields is going to be a reference to some data, and the other field is going to be a reference to a node, the next node. Often we call that field next. Think of this node as a single cell in an array. The data field is what's stored in that location of the array. And the next, well, arrays don't really need to keep track of a next, because arrays next is always in just index plus 1. But a node needs to have a reference to a node that exists, that is its next one. Yeah. So think of it like this. Imagine I have a reference variable called head. Head is not a node. It's a reference variable to a node. Okay? This linked structure has 4 nodes in it. Each of those 4 nodes has one piece of data in it. And each of those 4 nodes knows what its next is. Head, the node that head references next is that like yellowy green one. Its next is that like teal, turquoise, cyan, whatever color that is. Its next is that black one, and its next is, well, nothing, it's null. So this would be analogous to looking at an array with 4 things in it, the data being the 4 pieces of data in the array, and the next being like, well, the light blue one, gray, I can't tell what color that is index 0. That's index 1, index 2, index 3. But we don't index this thing. You can't index nodes like this. The way we do the indexing is through the nexts. So when you look at that picture, let's hit pause on what it says right here. If I had an array and I said, how do you access the data at the first index? Well, you say, well, that's easy. Assuming head is a reference to an array, you would say head at index 0, and you get the first thing. That's not how we do it with a link structure. What I would say is I would say head is a reference variable to a node, and I want to access that node's field. I'm going to have some accessor method for that node's field called like getData. So I'd say head.getData. And there, I got the data from the thing at the beginning of the link structure. How do I get access from the second node's data? Well, if this was an array, that's easy. Index 1 is the thing at the second position in the array. But we have a link structure, and I can't do that very easily. I would have to say head, get me your next data. So I'd say head.getNext, which is a reference to the green-yellow one, .getData. I need to ask that one to get its data. And we'll pick up here Tuesday.